You might catch that this recording is different from that you experienced in the classroom on Wednesday. That's because actually I had to re-record it because I forgot to hit the record button. So anyway, I'm at my desk now, but just again, a little bit about myself. My undergrad degree is from the University of Northern Iowa, and then I commuted from Burlington to Macomb to finish up my degree at WIU in Macomb, both excellent schools. So I've been doing this, I think I mentioned, for about 13 years. So just to kind of get our feet wet in lecture, kind of need to, anytime you take a class, talk about kind of the words that go along with the class. And so, for instance, what is chemistry? Chemistry is the study of the different elements and how those elements combine to create what we call compounds. So what is matter? Matter is anything that has mass and occupies space. And again, I think I know I did some different things in lecture, and I can't remember what I did in lecture, so this is just maybe more an abbreviated version. One of the cool things about matter is that matter is made up of atoms. And so here, if we were to look closely at the material that is associated with this aluminum can, we would actually see individual atoms that are stuck together because it's in a solid phase. Okay, solid phase is atoms that are stuck together real closely. These are all aluminum, the same atom. These are all aluminum atoms. If we were to kind of switch gears, and now instead of talking about a pure element like the aluminum in the aluminum can, if we were to talk about this liquid that is in this ethanol bottle of ethanol, it's a clear liquid, and the liquid actually is repeating units. And I know I asked in lecture, and I told you that those black ones are carbon atoms, those red balls are oxygen atoms, and those little white balls are hydrogen atoms. So actually the structure for ethanol here is two carbons stuck together, and then one of the carbon has what we call a hydroxyl group, an oxygen and a hydrogen, and then to kind of create the balance around the carbons, we have more hydrogen. So that is ethanol. Yeah, so all matter is made up of atoms. We have an element there and a compound. So this actually is, I said it kind of looks like take an egg carton and put it upside down, but what you're seeing kind of hidden down in here is the nucleus of an atom, the center of an atom. And as you know, in the center of an atom, or maybe you don't know, but we'll be talking more about how an atom is structured. But in the center of an atom are the neutrons and the protons. And then outside of the nucleus, the center of an atom, are the electrons. So kind of as we're looking at this picture, this is kind of the electrons in kind of a cloud outside the nucleus that's creating the edge of an atom. Atoms are very small. I know it looks like atoms are pretty big right here, but they are very small. This is a very powerful telescope. So this actually is showing you kind of the outline of a helical DNA structure. Okay. Again, a telescope that a microscope that we don't have in the chemistry lab. Then we spent a little bit of time talking about the three main physical phases of matter. So matter, and here we're showing the matter happens to be water molecules. Matter can either be a solid, a gas, or a liquid. And one of the things I didn't emphasize in lecture, but since I have you here, I'll kind of see if you buy this. So actually, here in its solid phase, okay, matter is close together. And the reason it's close together is it's stuck with lots of bonds. It's lots of IM, intermolecular bonds. Okay, and over here at the other end of the spectrum, when matter is a gas, basically it's far apart, and basically it has no bonds. The one thing, like I said, I don't know if I mentioned in lecture at this point or not, is that over here, when matter is a gas, it actually has lots of motion. Over here, when it's a solid, it has not much motion. Okay. Then your textbook does kind of a version of this, but I've done this with students before. When we talk about matter in its solid phase, then we would say that the chunk of matter is got, if it's a solid, it's rigid, and so in that sense, it has a size that won't change, and so we call it a definite, or excuse me, it has a shape that won't change, so we call it a definite shape, and its volume will basically stay the same. So it has a definite size and a definite shape. And then kind of related to why it's so rigid like that with regard to its shape and its size is it has a lot of these intermolecular bonds. It has a lot of bonds. And it although it just kind of wiggles or vibrates, there's not much kinetic energy. Kinetic energy, I don't know if you've run into this before, but kinetic energy is the energy of something that's moving. So it has a low amount of motion, low amount of kinetic energy. With regard to liquids, now they also have a definite volume per se, but the shape can morph into the container that's holding the liquid. So we say the liquid has an indefinite shape. The amount of intermolecular bonds is kind of intermediate, and so the amount of kinetic energy is also intermediate. If we compare then that to a gas, now gases is my favorite physical phase. I just love the energy that gas particles have, and they're so independent. So gas particles basically will give them as much room. Will take, excuse me, as much room as you give them. So gases will take on the volume of the container that you're confining the gas to, and they'll also take on the shape of the container that you put them in. So gases totally rock. With regard to intermolecular bonds, we say basically there are no intermolecular bonds between gas particles. They're just like totally totally on their own, totally independent. And the other thing is they have lots of motion, lots of kinetic energy. Very good. So here is a figure from your textbook. Oops, almost. So intermolecular bonds, what do we mean by that? Well, we mean that the bonds that are either kind of joining a pair of ions, and we'll talk what's the difference between an ion or a molecule. Or it could be joining an ion and a molecule, or it could be joining a molecule and a molecule. So when we kind of think about in an ice cube, all of those water molecules that are stuck together, they're stuck together with these intermolecular bonds. Kind of think of it that way. I'm not going to show you this video, but just to kind of remind you what this video does. All matter has motion, so even if matter is in its solid state, it has a little bit of what we just call kind of vibrational motion. Matter in its gaseous state has the most amount of motion. So here is that table from your textbook, table from your textbook. Again, solid has motion, but not as much. Okay. Particles are close together. The solids have definite shape and definite volume. And you can't, what we say, compress them, so they are incompressible. With regard to gases, gases have the most amount of motion. The particles are far apart, and they have both an indefinite shape and volume. The gases are compressible. Liquids, we generally say, are incompressible. Liquids, although they take on the shape of their container, their volume is fixed. And I think we're okay with that. So then here's where, let me take a quick shot of this. Here's where I stopped lecture. So hopefully we're on track, and this assignment is due on Friday.